Okay, well, good day to everybody. This is DK with Mr. V Amps, and we have something similar but different today. We have a box. Yeah, and inside the box is a Peterson Strobe tuner model 420. And the box is on some kind of hinges here. The hinges don't come off. This is an older piece. Some people are saying these are late 60s. I'm thinking they might be, this seems more like 70s to me. But it's a strobo tuner. It's not tremendously heavy despite being a suitcase, and it has its own built-in microphone as well as an input jack to plug your stuff and things into. As far as what I see about it, somebody has doodled a bunch of letters around here and put this mark here, so I can tell right out of the gate that this knob has come off kilter. And this 440 adjustment knob was stiff as a board, so that probably needs some lubrication. Our contrast pot here feels a little stiff. So I think we're off to a good start. I think this is going to be a fairly straightforward unit to doctor up. So let's just do a little initial testing on it, and then we'll go from there. Okay, so we've plugged it in, and I have on the line that person doodled here, this should be the 440A. So we'll turn it on here and see what happens. Okay, so it spins. And the contrast, I think, functions a lot like the gain does on a Conn. And it looks like this image clarifier high and low, it looks like it turns on a high neon or a lower neon. It looks like it kind of flip-flops between which one's brighter. So if we're tuning an upper register, which the A440 would be 3, probably makes sense to use, I don't know, the low and the high. It's like right in the middle. We'll see. So we'll feed it our gritty sounding 440. And we'll see if we can get that. It's trying to stop. Okay, so in order to get the 440 to stop, I've got to come 5 cents over to get that to stop. This A440 isn't usually that bad, so I'm going to guess this knob might be a little out of cal too. And I'll have to get a true 440 to set it, which is fine. Okay, so I come over here, all the way over, we're at 50 sharp. Let's go all the way over here, and we're, you know, it's close. This overreaches a little bit. Okay, so that's the quote-unquote agreed upon 440. I'm supposed to be reading band 3, and band 3 doesn't look very sharp. See how it looks on this side. Okay, now if I'm on low to read band 3, let's see how that does. Does that clarify it? Does that make it better? Does that make it worse? I'm wondering why it says A3 equals 440, because the band 3 doesn't even come close to stopping there. And all in all, the Conns, it's the 4th band. So, yeah, to make that stop, we have to be 4 degrees off there. So it's just a matter of deciding what A440 is and just kind of adjusting that a smidge. Let's play with a few other pitches and see how it does. Like I say, this tone generator is not super accurate. It's not that bad, but it's not that great either. So G sharp. That's supposed to be G sharp. Why is this? What is this doing? Let's make sure our A is really and truly good in there. Okay, there's our A. Yep. Okay. That's what it looks like on the Conn with all of its annoying harmonics. Let's try G sharp. Okay, that looks like vomit. That's supposed to be a G. And okay. That's allegedly supposed to be a G, and let's try F sharp, or I'm sorry, what am I doing? I'm going the wrong way. I'm going down here and I'm not paying attention. Okay. Okay, so there's A sharp. Okay, that looks better. What am I doing? I'm running this the one direction and I'm running the tuner the other direction. Call me used to the other. There's the B. That doesn't look so bad. Yeah, it looks like the general calibration is just off just a pinch here. C, that looks acceptable. C sharp looks acceptable. D looks acceptable. D sharp looks acceptable. Yeah, these higher ranges actually look really nice on here. Okay, we're back to A. These higher pitches are just like zeroing in beautifully. And I noticed, like I say, we have to be kind of 3 cents off the middle here to be accurate. Or according to this Sabine, which the Sabine's a smidge off. So what we'll do is we'll find a perfect A440 with our Conn, Strobe Conn. And then we'll go from there, because if anything, if I trust anything, it's that. Okay, so this is a low A sharp. What are we on? We're on a D. That should be a nice low D. Let's try the clarifier for low, see how that does. I like the clarifier on high, if you ask me. This clarifier on low looks kind of yucky. Probably because this thing doesn't go super duper low. It's probably for registering the lowest of the bass notes. And the contrast does function a lot like the gain knob does on the Strobe Conns. Okay, so initial checkout is passed. It seems to work. What we'll want to do is I'll want to put this on, let's just put this on A right now. And the pointer is supposed to be here, not off kilter by 5 degrees. It's like everything just got twisted 5 degrees on this. I don't know. So we'll straighten that knob out and scrub the letters off and give this thing a bath, and then we'll verify and double check its calibration and see just how much this agrees with our legendary Strobe Conn. So let's pop the lid off this thing. Okay, so we have it out of the box. This one is using neons. I know the newest ones use LEDs, but that's using neons like the Conns did. I think this was built at the same time Conn was still making these. I think this is like when Peterson licensed the technology. Caps on that board. We have just some resistors, ceramics, there's a couple transistors, and what looks like either little polyprops. Yeah, those look like little polys. Got some chips down here. I'm sure these chips are probably for setting oscillators and setting, you know, standard frequencies. Or they might be part of the audio circuit. Got a couple of ceramic caps hiding behind there. Those are probably for the motor run. And a few electrolytics here. We're just inspecting them to make sure they don't look like they've wet the bed. I mean, things work okay. Okay, this is weird. Not necessarily like it's the end of the world, but there's two legs coming out of that cap and one leg coming out of the top. So that's a dual cap. This is two 10 microfarad at 100 volts. Okay, it's a unique cap. A couple big axials over here. There's the rectifier, so the power must come in here because there's 4 diodes and that looks like a dropper. Okay. And there's our transformer, so I'm sure electricity goes in there and then gets dropped. I don't see any signs of leaking around here. That's good. We got some old school Illinois caps over here. And what's interesting is a lot of these tuners don't have oodles of miles on them, so unlike a home stereo that might have been on and on and on and on and on, you know, a lot of these may have been sitting on the shelf and turned on once in a while, so the odds of this thing being abused or whatever, and I don't want to be rotten, but when you look at something like an old Fender amp, they had a habit of running the caps and the equipment at just like the bleeding edge of its capability. And I found on most of this precision stuff, like these Conns and whatnot, they don't run this stuff on the bleeding edge, not even close. And a lot of this stuff is still healthy and functional. So I don't want to go over the top trying to restore this. Let's just dust it, clean it up, set the knobs, and see where it gets us. Okay, so why was the note dial, we're cleaning up the face by the way, why was the note dial crooked? It looks like somebody had a round, smooth switch here, kind of like this one for the 440 adjustment, but somebody kind of dremeled and drilled on this side, and they dremeled and drilled off kilter. So there's essentially 2 ways to fix that. We can try to fill all of this out and then make a new flat spot, or no flat spot. It's going to be JB Weld and whatever. But I mean, it looks like somebody just did this with a Dremel, and then they made another flat spot on the other side. So what? I don't get it. What were they doing? Anyway, my option, my choice instead, you can see this board's a little crooked now. This switch, it's still not touching anything or whatever, and the wires had enough give that I was able to rotate this switch just a little bit, you know, 3-4 degrees that way, and tighten it back down, and that should square that up without having to do too much wrestling and surgery. So that worked. I can click through the stuff and it stays, but there's actually some little bit of offset here with the plastic relative to the metal, so that's just wear and tear, so we'll probably just put a little speck of glue or something on that to solve that. I think that'll do it. Okay, so I've got the face pretty well cleaned up, as good as we're going to get it, I think. And we've got the wheels set correctly, because before our A440 was off by about 3 cents according to the wheel here. When all else fails, when you try to calibrate these, tuning forks will change with temperature and whatever, and so you need to have an accurate reference pitch. And quite frankly, the most accurate thing we have here at the shop is our Conn back there. Hey, you can hear me talking, but that big boy is just disgustingly accurate because it's mechanical, meaning that once you decide what 440 is, everything else in the system has to follow that. It's all gear driven, it's all a ratio. and our Peterson agrees with our big Conn, so if they agree with each other, then I would call this one working just fine. Yeah, so we've got that part cleaned up, we've got the innards cleaned, and we've cleaned the outwards, cleaned up the box, scrubbed all the dirt off of it and all that. So we've only got one little nick in the Tolex, and I'm kind of contemplating about covering that up. We might sneak just a little bit of black nail polish on that only nick, and then it'll make it harder to see. But the rest of it's all cleaned up, looking good, pretty. I'm gonna let the lid dry out. The lid does come off, by the way. It took me a little while to figure out how it unhooks, but it does unhook, so the lid does come off. So yeah, we're gonna put this back together, give it a final test, and call it a victory. Okay, for visual's sake, it's kind of hard to get them both in the picture, but I've got a guitar and the tone knob is rolled all the way back, so it's kind of a muddy, dry, dull sound, which is what you want when you're tuning one of these things, so it can hear the fundamental and not all the harmonics. So we'll start with the Peterson set to the E. Okay, because we have two E's on the guitar, right? So the Peterson's at E, and the Conn is up there. It's up above, up there on the shelf. So I'm going to look at the Conn, and we'll get the Conn to say the notes in tune, and then we'll look at the Peterson and see if they agree. Okay, the Conn says the high E is in tune, but it might just be an absolute tiny hair flat, if at all. And the Peterson says it is dead on. The Conn tends to be a little bit more finicky, I think, but that string is definitely in tune. Let's try the low E. The Conn says it's a little bit flat. Now the Conn says it's a little bit sharp. Now the Conn says, and I'm not looking at this Peterson, so if it's inaccurate, you can tell me. Okay, that looks good on the Conn. And it looks spot on the Peterson. Okay, so far we're in agreement on the E's. So let's move to D. Okay, here's D. And the Conn says that looks really good. If it's doing anything, it might be just a minuscule amount flat. And I see the exact same result on the Peterson, so awesome. Doing great. Alright, so now we go to B. Right? And our Conn says we're a little flat. Just a little. Now the Conn says I just took it sharp, so. This string is so creepy. Okay, that looks pretty good. The same result from both tuners. This is very good result so far, because once we set what our A440 is, it's impossible for these tuners to disagree, essentially. Here's our A. Precise agreement. So I think that's all the strings we have on our guitar. So hear how it sounds underwater. I have the tone knob rolled all the way back, because if I try to tune it with it in here, I'm going to see a lot more harmonics. Oh, that went flat on me. The A seems to be the hardest one to read on the Peterson, but the A is one of the hardest ones to read in general. The Peterson 420 strobe tuner agrees perfectly with the mighty Conn, which is pictured above. There's a really horrible angle. It's like the creepy monster movie shot. But it's up there, and that's what I'm actually tuning with. So these two are in agreement. I'm going to say this Peterson is working absolutely spot on beautifully. And it is ready to... I've got it all cleaned up and everything. I basically just need to make sure that the lid is dry because I washed it. And once the lid's dry, we put it back together, and it's ready to find its next owner. And we should be able to plug our guitar straight into it. Let's make sure that our input jack works. That's about the only thing I haven't tested. So, what note are we on? We're on A, right? So we'll plug that in there. It has a lot of shielding on that. Let's try the... Yep, it hears the guitar just fine. Let's adjust its sensitivity. Its contrast is its sensitivity, so it's a kind of a brightness thing. Yeah, that works just fine. So let's try another note. Let's try the G. That's a good one. Yep. So yeah, we're good. We be strobo tuning. I'm happy. Are you happy? Of course you're happy. Everybody's happy. Despite being a solid state, unlike the mighty Conn units that we've used that are tube, I'd say this Peterson passes the test. It's good. I like it. All is well. Thanks for watching. Have a great day.